Hello friends, welcome to lecture number 5 of Fourier series, and these are the topics we are going to discuss here in this video. Discontinuous function, even function, odd function, half range series, right? So before we start, please subscribe the channel if you're new to my channel, and share with your friends. If you like my videos, hit the thumbs up button. Also hit the bell icon so that you get notified when new video will be uploaded, right? So now you see links of the previous lectures given in the description box. Okay, if you haven't watched, then please go through them first, then it will be easier to understand. Okay, so now let's start. So now let us discuss about discontinuous function, right? Discontinuous function. And suppose we have a function f of x. Suppose we have a function f of x, so such that at a point x is equal to c, the left hand limit of this function is not equal to the right hand limit, right? So I hope that you have the concept, you know that what is left hand limit and right hand limit. You have studied in senior secondary level, I think, right? So now you are a student of BSc or MSc, so you should know these things. So now you see then this function f of x is discontinuous because at this point the left hand and right hand limit of this function, right, at this point say these two are not equal, so this function f of x is said to be discontinuous at the point x is equal to c, right? In that case, the value of this function at this point as x is equal to c, that will be given by that value of this function f of x at c, that will be given by the average value of the left hand and right hand limits, right? Average of the left hand and right hand limits. Okay. So sorry. Okay. So that means suppose we have let me draw a graph here. Suppose that to explain this, so this is x, this is y, which is equal to f of x, and its graph is something like, suppose this is the graph of this function, right? And this is the point c, x is equal to c, suppose, right? At this point this function is not continuous, right? Discontinuous. Okay, so here at this point this is x is equal to c. At this point its value of the left hand limit will be given by this point, which is nothing but f of c minus 0, right? So which means value of this function, right, at the point c, value of the left hand limit, right? And this point represents the value of the right hand limit at the point c, right? C plus 0, right? So in that case, at this point, what will be the value of this function? So we can take the average of these two, right? So hope you have understood this concept. Now let me take a question first. So find the Fourier series of the function f of x is equal to this. So this is a discontinuous function, you can see clearly it is discontinuous at x is equal to 0, right? So and we need to deduce the relation. This relation is equal to pi square by 3, right? So now let me solve it. So f of x is equal to, this is the function, right? So it is let us consider the Fourier expansion of this series be like this: a naught by 2 plus summation from n is equal to 1 to infinity a n cos nx, and summation from 1 to infinity b n sin nx, right? This is suppose equation number 1. So we know that a n is given by 1 by pi from minus pi to plus pi f of x dx, right? So here you see So in the first case, f of x for 0 to minus pi, from minus pi to 0, x greater than minus pi less than 0, in this range f of x is minus pi, so which can be taken out of the integral, right? So then dx, then plus. So here you see, though we have taken here minus pi to plus pi, but this value of this f of x from minus pi to 0, then 0 to pi are different, right? So we have to take as a sum of two integrals, right? Then next one will be 0 to plus pi. So f of x, now the f of x is x, right? Then dx. Okay, so let us integrate and let me evaluate it, right? So integration of x is x squared by 2. We are integrating it from 0 to pi, right? So integration of dx is simply x, right? So hope you know these things. Okay, very simple. Now let's put the limits, and then what you will get. Just wait, let me clean these things. Okay. So then what you are gonna get, you're gonna have it, right? So putting the upper limits and lower limits, we have got this value. Then let me simplify this, right? Okay, it's gonna give you, but this is the value of a. So this is the value of a naught. So now let me find bn, an first. So let me find an. Okay, so 1 by pi minus pi to plus pi f of x cos nx, right? So again, let me write the function here. This is the function which is discontinuous at 0, right? So at 0, this is the boundary line where we are getting two different values of these functions, right? So 1 by pi minus pi to 0, here f of x is for this minus pi to 0, f of x is minus pi, so that's why we're gonna have here minus pi here, which is written outside the integral as it is constant. Then cos nx plus, then integration from 0 to pi, in this case 0 to pi, here the function is x, so x cos x dx, right? So now let us integrate. If we integrate this part, then what are we gonna get? So this is the result we're gonna have. Then here let us apply u into v rule, right? Integration u v dx. This is integration u integration of v dx minus integration derivative of u integration v dx, right? So let us apply this, and applying this, taking this one as u and v respectively, x is taken as u, cos nx is taken as v. Then doing so, we have got this. So I hope you can do the integration yourself, right? Because I have shown many times already in previous lectures, right? So now putting the upper limits and lower limits, this for x is equal to pi, the terms containing sign will be 0, right? Terms containing sign will be 0. We can deal with only the term containing cos. So, and if you do so, then you will get this result, right? So if you put cos nx here, if you put pi here, then you will get cos n pi by n square. And if you put 0 here, then cos 0 is 1, so that's why 1 by n square, that's what we have got. So this is the result we have got. So this is the value of an. So now let's find bn. Okay, so bn will be given by 1 by pi, then again minus pi to plus pi, f of x sin nx dx, right? So here this also can be written as minus pi to here minus pi s should be taken outside, because this is the function. Let me write here again, and right, for you see, for x is equal to for x less than 0 greater than minus pi, for minus pi to 0, f of x is minus pi. So f of x, this is going to be replaced by minus pi, and this is taken outside, right, taken outside the integral, as it is a constant term. So then sin nx dx, so again 0 to pi. Now this is from 0 to pi, this is x, so sin nx dx, right. So now let me integrate. Okay. If we integrate this, we're gonna get this results, right. Here apply again u into integral, and doing so we have got this result, right. Now let's put the values. Here again you see this term containing sine will be 0 for pi, and for 0 also, x is equal to 0 also, it's going to be 0, right. We're going to deal with the terms containing x only, right. So here for this first part, if you put 0 and pi, then you're going to get this result, right? Putting 0 here, it will be 1 by n, and this minus minus, that's going to be plus, right. So then pi by n is taken common, because here you see when you will put here minus pi, then it will be cos n pi by n, and that gonna be right. Just as we will get n here as well, so 1 by n is taken common, then here we have got pi. Let me explain it properly. So minus pi, we have here minus pi. If you put 0, then you will get minus 1 by n, then minus cos n pi by n. So from here we have taken 1 by n common with minus pi, that's going to be n pi, right. Then this minus will be plus, and on taking minus sign, right, just wait. Okay, just taking minus 1 by n common, this is going to be plus pi by n. Here we will have 1 minus cos n pi, as we have minus sign here. So when you will subtract that minus cos n pi by n, then it is going to be plus, right. So hope you know these things. So similarly, what if we put upper and lower limits in this term here? If you put here, if you put pi, and if you put 0 here, then it's going to be 0. So then if you put upper limits pi, then what you will get? So let me write here, this is going to be the result, right. So after simplification, we have, this is the bn, right. So now let's put the value of a and b and a naught in the equation number 1. So let me write the equation number 1 and a and b and a naught in the next slide. Okay, so let me go to the next slide. So this is the value of a n we have got, this is the value of a n, this one is a naught here. Now this is the value of a n, and this is the value of b n. This is the value of bn, and the equation number 1, let me put these values in equation number 1. Putting the values of a naught, an, and bn in equation number 1. This is the equation number 1, right. Okay, this is the equation number 1. So let's put the values here. Then we have got the Fourier series of the given function is of this form, right, is of this form. Okay, okay, now let me copy this and let me go to the next slide. Okay, and to deduce the relation, equal to relation. Okay, so f of x, that's gonna be equal to this that we have got in the previous slide. Okay, this is what we have got. Now let us expand the summation Okay, here you see cos n pi is minus 1 to the power n, right? Then okay, here also minus 1 to the power n, because cos n pi is this, right? Okay, so now let us expand this sum. So if you put 1 here, what you will get? If you put 1 here, n is equal to 1, so this minus 1 to the power 1, that's going to be minus 1, minus 1, minus 1, that's going to be minus 2, right? And if you put here 1, then that's going to be 1 over pi. That means you're going to get minus 2 by pi. And here if you put 1, then cos nx, right? So that's what we're going to get, right? So if you put n is equal to 2 here, that's going to be plus 1, then minus 1 plus 1, that's going to be 0. So there will be no cos 2x term. So let's put 3 now. If you put 3, again you will get minus 2 by pi, which is already taken common. That means each and every time you will get this minus 2 by pi if you expand. And for even numbers, n is equal to 2, 4, 6, this term going to be 0. That's why this whole thing is going to be 0, right? So hope you have understood this. So now that's why our series is going to be like this. Sorry, here I have to put the plus sign. So this is the series we're going to have, and so on. If you expand the next part, if you expand this part, then what you will get? You're going to get this result, right? So let me explain how. Okay, now here you see, if you put 1, n is equal to 1, if you put n is equal to 1 here, then this is going to be 1 by 1, and here this is going to be plus 2, because minus 1 to the power 1, that's going to be minus 1, minus 1 into minus 2, that's going to be plus 2, 1 plus 2, that's going to be 3 by n, right? And sorry, 3 by 1, n is equal to 1, as we are taking 3 by 1 means 3, and here sine x, right? 3 sine x. Now when you will put n is equal to 2 here, so this is going to be plus 1 into minus 2, that's going to be minus 2, and if you subtract, then you will get minus 1, and 1 by, here if you put 2, that's going to be 1 by 2, minus 1 by 2, and here it will be sine 2x, so minus sine 2x by 2, right? So similarly, if you put here n is equal to 3, if you put n is equal to 3 for odd numbers, this minus 1 to the power n, that's going to be minus 1, minus 1 into 2, that's going to be plus 2, and then 1 plus 2, then 1 plus 2, that's going to be 3. So here we're going to put 3 as well. So 3 will be cancelled, and here it will be sine twice x, and so on. That's how we're going to get this series. So hope you have understood, right? So this is the required Fourier series. Now here you see at the point f is equal to 0. So let me take this as this one as equation number 2. Let me take this equation number 2. So here you see at 0, if you put x is equal to 0, those terms containing sine, this is going to be 0, right? So, and terms containing cos, those going to be 1, right? Because sine cos 0 is 1, so that's why we're going to get this result, right? So this is equation number 3. Now let me go to the next slide. Okay, so let me write the equation number 3 again. So this is the function here. Let me write the function again, because I need this function again to explain further. So this function is discontinuous at x is equal to 0. You can see clearly, right? It is discontinuous at 0, because at the same point we have got different values, right? So according to that concept that we have discussed already, that when we have a discontinuous function at a point x is equal to c, that's going to be the average of the left hand and right hand limits, right? So f0 minus 0, that means this is the value of the left hand limit, and this is the value of the right hand limit, right? So the value of the left hand limit will be here according to this given function, that's going to be minus pi, and for the right hand limit, that will be x, which is at this point x is equal to 0, that's going to be 0, right? F of 0 will be 0 at this point. So for the right hand limit, so we can write minus pi plus 0, right? So that's what we can write. So hope you have understood this. Then this is going to be equal to minus pi by 2. This is suppose equation number 4. Now from 3 and 4, from these two equations, from this 3 and 4, we can write what we can write, that this is also f is equal to 0, right? So this is minus pi by 2 will be equal to this series, right? So from these two equations we have got this result. Okay, this one can be written as 1 by 1 square. This can be written as 1 by 1 square, right? So now let me go to the next slide and let me simplify this result. So what we have got from equation 3 and 4, we have got this result, right? So that's the result we have got. And if you simplify this, so hope you can do this simplification part by yourself, so then you will get this result. So now here you see we have got this. Now multiply pi by 2 on both sides, minus pi by 2 on both sides, then you will get this result. So this is the relation we need to show, right? So this is 1 by 1 square, that's what we can write. So this is the required relation. So now let us discuss about the odd function and even function. Let me go to the next slide. Okay, so what do we mean by odd function, right? A function is said to be odd function. A function is said to be odd function if, you know, f of minus x is equal to minus f of x. For example, suppose we have f of x is equal to x cube, right? If you put minus x, then it will be minus x cube, minus x whole cube, that's going to be equal to minus x cube, right? Minus x cube means it is nothing but minus f of x, because x cube is f of x, right? So here you see we have got minus f of x is equal to minus f of x. F of minus x is equal to, we have got minus f of x. So in such this kind of function are known as odd function, right? So similarly, let me write even function. A function is said to be even function if f of x, f of minus x is equal to f of x. For example, we have suppose f of x is equal to cos x. So minus f of x, that's when we cos minus x. Cos of minus x will be again cos of x. I think you know these things, right? Because here you see for minus angle, this is theta equal to suppose minus x, right? So then you will come to this fourth quadrant where cos is positive. So cos minus x is always plus cos x, right? So this is even function. Cos x is again f of x, right? As we have got f of minus x is equal to f of x, that's why it is even function, right? So now let us take a question. Yeah. So before we are going to take a question, let me write a property, very important property of integral, definite integral. So minus a to plus a, if you have an integration minus a to plus a f of x dx, then you can write to 0 to a f of x dx if the function is even, right? That means f of minus x is equal to f of x means if the function is even, right? And it will be 0 if the function is odd. That means f of x is equal to minus f of x. The f of minus x is equal to minus f of x. That means if the function is odd, right? Then the result of this integral will be 0, right? So suppose we have a function, this is f of x, be a function in this interval, and f of x is equal to this in the corresponding Fourier series is given by this, right? So then here you see, let me write this again. So this is the function f of x in this interval, and its Fourier series can be written in this form, right? So hope you know these things, right? So now you see a naught is given by this integral minus pi to plus pi, and an is given by this integral f of x cos nx dx, and bn is given by this integral, right? So now you can see if the function is let me write the property of the definite integral again. So if it is an even function, you will get this result for even function, and if it is odd, you're gonna get 0, right? So in that case, here you see if f of x is odd, so if this is odd, then according to this rule you're gonna get 0, right? So n is equal to 0, n not is also 0, n is equal to 0, because here you see when it will be odd, f of x is odd, so for minus f of x you will get minus f of x. For f of minus x you will get minus f of x. Then cos is even, so cos of minus x, then you're gonna get cos of x, right? So cos of x then minus f of x, you're gonna get negative for f of minus x. That's why this as a whole this becomes odd, right? So that means when you will put when you will replace the x by minus x, if you take this whole thing as capital F of x, right? If you take this whole thing as a capital F of x for capital minus x, f of capital capital F of minus x, you will get small f of minus x cos of n minus x, right? Which will be minus, if this function is odd, f of x is odd, then you will get minus f of x is f of minus x is minus f of x, right? And then cos minus theta is cos theta, right? Cos nx. So this is nothing but minus capital F of x. So for capital F of minus x we are getting minus capital F of x. So as a whole this function is odd, right? So in that case, according to this result, this identity, this function should be 0. So hope you have understood. That's why a not an when the function is odd, these two will be 0, and bn, this one here you see, in this case sin nx is also odd, this is also odd. If you put if you replace the x by minus x, if you consider this whole thing as f of x, and if you take here sine, right, sine of minus x, that's going to be minus sine x, sine nx, minus sine nx. So this is also minus, this is also minus. Now it becomes plus. So in this case, if this f of x is odd, so f of minus x becomes plus f of x. So that's why as a whole this function will be even. So that's why we will get bn according to this property. We will get bn is equal to this, right? So hope you have understood. Now let me clean these things. Now you see, if the function is even, then a naught will be equal to this, right? According to this rule, identity, and n will be given by this. Okay, for even function, this is the even function, and if this is even and this is also even, that's why we're gonna apply, we're gonna get this result for a naught and an. For bn, this is even, if this f of x is even, right? Then what you will get. But in this case sin nx, and this is odd, right? This is odd and this is even. So if you replace the x by minus x, this function, this as a whole, this function will be odd, right? So in this case we will get bn is equal to 0, right? For even f of x is even, we will get bn is equal to 0. Hope you have understood. Now let me take a question. So obtain the Fourier series of for x is equal to f of x is equal to x cube. So this is the range here, and let me write the solution. This is the given function. Let me consider. Okay, this is the Fourier series, and let it be equation number 1, right? So let it be equation number 1. Now you see, f of minus x here, minus x whole cube, that's going to be minus x cube, that is minus f of x, right? So which means this function is odd, right? Odd function. So a naught and an will be equal to 0, because we have already got in the previous slide, we have already discussed. Here you see, for odd function these two must be 0. So bn will be equal to, this is the bn, that's going to be equal to So n and n naught, these are 0, bn will be equal to this, right? F of x sin nx dx. So again we're gonna put f of x, that is x cube here. In this case f of x is x cube, right? So sin nx. Now we will integrate applying this rule. Here you see, what does it mean? Because you see, here you see, if you apply this integration u v rule here, okay, so when you will integrate this, considering this like this, x cube integration of sin nx, that's going to be minus cos nx by n, then minus derivative of x cube, that is twice x, thrice x square, then again integration of sin nx, that's going to be minus cos nx by n dx. Again here you see, again you have to apply here u by v rule successively, okay? So this situation will be going to be involved in many steps, so that's why we're going to apply this rule here. So what does it mean? Here you see, so first take this x cube as u. First let us take this x cube as u, right? X cube as u, sin nx as v, okay? So here v1 represents integration of v, and v2 represents integration of v1, okay? So v2 is the integral of v1, v3 is the integral of v2, right? So hope you have understood these things, okay? So that means, as you have got here, this is the integration of v, so this is v1, so v, and then if you integrate it again, that's going to be v2. So hope you have understood this, right? So let me see, v1 is integration of v dx, then v1 is integration of v dx, right? Similarly v2 is integration of v1 dx, so on, right? So hope you have understood this. If you apply this rule, then you will get what you will get. You will get this result, okay? So let me write directly the result, okay? Okay, this is the result you're gonna get, 0 to pi. Let me go to the next. And let me tell you one more thing. As I have taken v1 as integration of v dx, then v2 is taken as integration of v1 dx. Similarly, we have taken u dash is derivative of u with respect to x, and u double dash, sorry, let me write here, u double dash that we have used here, u double dash, this is the u double dash, this is the derivative of u dash, or you can say second order derivative of u. So u triple dash, that's going to be third order derivative of u, or you can say derivative of u double dash, okay? This can be obtained by derivative of u double dash. This is derivative of u double dash is nothing but your u triple dash. So hope you have understood these things, okay? Now let me go to the next slide. So this is the last result we have got. Now let's put the upper limit and lower limits, then you will get this result. Because you see, when you have 4 pi and 0, the terms containing signs becomes 0, right? We're going to deal with the terms containing zeros, cos only, right? So hope you know these things, because we have done many times these things. So that's why we're going to get this result. So here cos n pi is nothing but minus 1 to the power n, right? So if you have problem in integration, so plus we can solve more problems, such type of problems involving half range series. Because here you see this series, let me go to the previous slides, okay? So here you see, in this case, in these cases, here you can notice one thing. So this here the interval is minus a to plus a. Now it's becomes 0 to a, which is the half range of this range. So that's why such kind of series, that series will be obtained, okay? series will be obtained, and after expressing this kind of function, either we will get cos series or sine series in such cases. Okay, and the range will be 0 to pi. That's why this series will be called half range series, right? Those series will be called half range series. So hope you have understood this. So we can solve more problems, more such type of problems in the next lecture. Okay, so stay connected. So take care and thank you for watching. See you in the next video. Bye.